Welcome to Class 10 Physics students. In this part of the video, we are discussing about the measuring instrument students. The first kind of measuring instrument is the common scale. Scale is calibrated in centimeters, and you know that a centimeter is divided into 10 equal parts. I can say 10 equal divisions, and each division has a length of 1 mm. It means that you can measure up to 1 mm accurately by using a common scale. Okay, students, you can measure a length which is equal to 1 mm by using a common scale. Then a question will arise. If the length is less than 1 mm, okay, you cannot measure it by using a common scale. That's why a new instrument is invented by Mr. Pierre VERNIER. He's a French scientist, I think. He accurately measured up to 1/10th of the millimeter. What you are watching on the screen is the schematic representation of a Vernier scale, students. Here, in this one, what I showed is 3, 4. It is the measuring scale. And if you watch it carefully, here says the students. Here it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is the main scale. Main scale has a minimum division of 1 mm. Okay, students, a common scale seems like this. If you watch it clearly, you will find. Okay, students, divided, or it is calibrated in inches. Upper, it is the inches, and lower, we have the scale in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Means it is up to 1 centimeter, students. By using this scale, you can measure the 10th of part of the 1 centimeter. It is up to 1 centimeter. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can measure 1/10 part of the centimeter accurately by using this. If it is more than or less than, more than you can measure, but it is less than, then we can't measure using a common scale. It's a common scale, students. Okay, students, to measure the lengths which are less than 1 mm, we have to use one more scale, a new scale. That is known as the Vernier caliper, students. Let's talk about the Vernier calipers. Unlike the main scale, a Vernier scale has 2 parts in, students. This one, what I am showing up to 4, it is extended. It is the main scale, students. It is the main scale. And this what? It is known as the Vernier scale. It is the Vernier scale, students. I hope you are understanding. This one is the main scale, and this one is the Vernier scale. If you watch it carefully, you will find 2 jaws which are attached to the main scale. These 2 are the rigid jaws, students. These 2 are the rigid jaws. I am calling this jaw as J1 and it is J2. J1 and J2 are the rigid jaws. And here I am calling it as the J3 and it is J4. J3 and J4 are the movable jaws because this one, this jocket, is moving over the main scale. Okay, students, it is fixed over the surface and it is moving over the surface. Okay, students, it's a slider. These are the lower jaws, J2 and J4. They have their own meaning. And these 3, 2, J1, J3, upper jaws. Okay, students. What is that? Additional to that, if you see, it is a schematic arrangement of the uh, vernier calipers. Okay, students, the same idea here. It is provided with a rod here, thin rod. Okay, students. This rod, say it is the thin rod, it has its own meaning. Here, lower jaws are used to measure the thickness of anything, students. Lower jaws are meant to measure the thickness or the length of anything. Okay, students, if you insert it, but any rod or any, and move it and fix it here, and you can measure the length. And what is the use of upper jaws? Upper jaws are used to measure the what's that inner diameter, students. Okay, students. Upper jaws are used to measure the inner diameters. And this thin rod, actually it is attached here, is measured to is used to measure the depths of the tubes or rods, anything, student. Tubes, not the rods, or don't have any depth. Here, tubes, the depths of the tube, students. These are the major uses of the vernier calipers. Okay, students. And the construction goes like this. As I explained, it consists of two scales. One is the main scale and second is the vernier scale. Okay, vernier scale is provided with two fixed jaws, it is J1 and J2. And this vernier scale provided with the two movable jaws, J3 and J4. And it is a jocket which is fixed over the main scale. It slides over the main scale very easily. Okay, here it is a screw which is used to fixes this vernier scale in tight with this main scale, students. Okay, students. Here I said if you take a common scale, you can measure up to 1 by 10th of the mm. See, 1 by 10th of the centimeter accurately. But what happens? If it is less than 1 mm, then we need in another and one more scale, and it is known as the vernier calipers. It is first invented by a French scientist named as Pierre VERNIER. Okay, students. Welcome to Quest Study Physics, students. In this video, we are going to discuss about the measuring instrument, students. Okay, students, the first kind of measuring instrument is the scale. Generally, we use this scale to measure the length. And if you watch this scale closely, you will find that a scale is calibrated over it. Not only one, two. Upper part is calibrated in inches and lower part in centimeters, students. That means we are following inches means what? FS system of the units and lower is CGS. What I am explaining here, actually, I am trying to tell that if you use a common scale to measure the lengths, you can measure the lengths accurately in centimeters and somewhat accurately in millimeters. Okay, students. If it is less than 1 millimeter, you cannot measure it accurately. Okay, students. To overcome this, a French scientist, Pierre VERNIER, invented a new scale. Later, it is called as vernier calipers. Okay, actually, it is vernier caliper. Okay, students. A vernier caliper is an instrument which is used to measure the lengths up to 1 by 10th of mm, which is used to measure 1 by 10th of mm accurately. Here we have to understand how it is possible to measure 1 by 10th of the mm accurately by using a vernier caliper. Here is a schematic representation of a vernier caliper, students. Unlike the main, what's the general scale or the common scale, what we are using. It doesn't have a single scale, but it has a set of scale, students. One is the fixed one and second is the movable. This part, here I showed you, it seems like a jocket. It is known as the vernier scale, students. And this one, it is a fixed scale. It's a common scale, students. Okay, students, the common scale is calibrated in centimeters here. See, we start with the 0 and we are coming up to here. And then I showed you 2, 3, 4, so on. So these kind of scales are, it means vernier calipers. They are of length around 15 centimeter, and some are up to 30 centimeters also. Here we are learning about the basics of the scale. That's why I do to some extent only here. Okay, students, and if you watch it, it is a jocket which is made of metal and is a slidable one, and it's provided with the screw. The function of the screw is here we inserted anything in between these two things. These two are known as the lower jaw, students. These are known as the lower jaws. Automatically, these two are the upper jaw, students. These two are the lower jaws, and these are the upper jaws, and they have their own meaning, students. Here, the lower jaws are meant to measure the length of the rods or any tubes. Okay, outer length of the rods, and as well as the tubes, and the thickness of the glass plates or the metal plates, anything. Okay, students, by using the lower jaws, we can measure the length and thickness, and we can measure the diameter of the balls, and as well as spheres, etc., by using the lower jaws. But the function of the upper jaws is, okay, students, to know the inner diameters of the tubes. Inner diameters of the tubes can be measured easily by using the upper jaws, students. It is the cap, and we have to know the inner diameter, okay, of this cap. Outer diameter can be found easily if you insert in between and fix it, and if you take the readings, and you will get the length of this one accurately. But inner, here we have to keep this one. Imagine it's a bigger one, and we have to move this till they are in contact inside of that. Then we will get the inner diameters. Additional to that, this one, this scale, the main scale is attached with a thin rod. Schematically, it can be shown like this. If it is the main scale and it is the vernier scale, okay, students, which is attached. Okay, here a thin rod is attached in this. This thin rod is used to measure the depths of tubes. It is it. If I remove this one, I will get a tube. And to measure the depth of the tube, we use this rod. Okay, students. These are the main parts and the functions of the inner jaws, and as well as lower jaws and upper jaws, and this thin rod, students. If you watch it clearly, these two jaws are movable and these two are the fixed. The jaws which are with the main scale or the fixed one, and these two are the movable ones, students. Students, let's know how a vernier calipers work. Students, let's know how a vernier caliper works. I already told you. It is the instrument which has more precision. That means you can measure the length of any object with smallest error. That means 1/10th of the millimeter accurately by using a vernier calipers. First, we have to understand how to measure any length by using a main scale. Then after, we will understand how we have to measure by using a vernier caliper. See, the students, is the main scale. Everyone knows about this. It is graduated in centimeters. It is 0, it started with the 0, and it's the 1 centimeter, and it's the 2 centimeter. Main scale. Okay, it is the meter scale what we are using. Okay, and the scale is calibrated into equal division, students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means what? 1 centimeter being divided into 10 equal parts. If you see this, you will get the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 centimeter being divided into 10 equal parts. Was this pencils, students, which is kept over? Here I am trying to explain you how we have to measure. Here we put the edge of this pencil, which is coinciding with 0 of the main scale. See this. Here I showed it as the A. And this pencil's this end is coinciding with the 0 of main scale. And see the tip of the pencil. If you watch it carefully, it is 1, it is 0.5 centimeter, 6, it is the 0.8, it is 0.9, and it is the 2. That means what? Each division is calibrated as 0.1 centimeter. Means what? 1 mm. 0.5, 0.6, 0.7, and 0.8. If you watch it, someone measured it as, what is said? It is 1.7 and it is lying in between 0.7 to 8. Someone said the length x, that means pencil length x is equal to 1.8 centimeter. Okay, students. And others said, y said it is not, it is 1.7 centimeter. Okay, students. And one said, z said it is 1.74 centimeter, and Mr. A said it is 1.78 centimeter. If you see with your naked eye, maybe in their view they are okay, because they one thought that this line, the B line, is in between 0.7 to 0.8. That's why he said it is 1.74, and someone watched the same thing as 1.78, and someone, he took the scale which is in front of 0.8 and he said that 0.8 means what? 1.8 centimeter. And someone, sir, he neglected this gap and he said it as the 1.7. If you watch it keenly, you will observe that the error, what they took, is a 1 mm only. It is lying in 1 mm only, because between 0.7 to 0.8, the scale is graduated as 1 mm. Maybe it is 1.74 or 1.78, or someone side is 1.76. We can't say exactly what is the right read. That means the minimum error can be equal to 1 mm. Okay, students, to avoid that error, vernier scale is used. Now, what's this diagram, students? See this, the upper part is the main scale and it is a slidable vernier scale. Okay, students, if you watch it carefully, here 0 of the main scale is coinciding with the 0 of the vernier scale. Two zeros are coinciding. Now see, here it is calibrated like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it is equal to 1 centimeter, students. Now what's this? The divisions in the vernier scale: 1, okay, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means what? This 10 divisions: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, students, it's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 divisions of the main scale. See, students. Yes, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 divisions of vernier scale. You watch it. 10 divisions of vernier scale are equal to 9 divisions of main scale. Observing students. 9 main scale divisions is equal to 10 vernier scale divisions, students. Are you understanding? 9 vernier scale, 10 vernier scale divisions are coinciding with the 9 main scale divisions. Okay, students. That means what? Each division of the main scale is 1/10 of the, what is that, millimeter. It's calibrated in that way. Okay, student. Now see, 10 vernier scale divisions are equal to 10 vernier scale divisions are equal to 9 main scale divisions. This is the main thing what you have to remember, students, while working with the vernier calipers. 10 vernier scale divisions is equal to 9 main scale divisions. What does it mean? One vernier scale division is equal to 9/10 of main scale division. Okay, students. One vernier scale division is equal to 9/10 of main scale division. In a vernier scale, the main thing what we have to find out is the least count. What is the least count? We have to understand here, students. Least count is the minimum length which can be measured accurately by any measuring instrument. Least count is the minimum length which can be measured accurately by any instrument. If you take this common scale, it's the meter scale, students. Least count is equal to 1 mm. Then we have to know what is the least count in the vernier scale, vernier caliper, vernier caliper. Okay, in vernier caliper, least count is equal to, here the difference of 1 MSD minus 1 VSD. Okay, students. So this 1 MSD minus 1 VSD. Now see, I said 10 vernier scale divisions is equal to 9 main scale divisions. Means 1 main scale division is equal to 9/10. What's that? 1 vernier scale division is equal to 9/10 main scale divisions. Or you can write it as 1 main scale division minus 1 VSD is equal to 9/10 MSD. This is an important formula, students. What is the least count of the instrument? That is 1 MSD minus 1 VSD. Or you can write it as 10 MSD minus 9 MSD by 10. Okay, students. It is 1/10 MSD. 1/10 MSD. Already I told you 1 MSD. 1 MSD is equal to 1 mm, I said. See here, students. It is divided into 10 equal parts. One part, that means what? The one division has a length which is equal to 1 mm. Here I am substituting the same here. 1/10 into 1 mm. Okay, students. That is 1/10th of mm means 0.1 mm. Okay, students. The least count of the vernier caliper says 0.1 mm. What does it mean? It means that you can measure 1/10th of the mm accurately by using a vernier caliper. Okay, students. I hope you understood. Here, what is the least count? It's the minimum value which can be measured accurately by any scale. Okay, if you take the main scale, that means common scale what we use. The minimum. One main scale division is equal to 1 mm. Here I show it. Okay, students. Here, what is the least count which can be measured by a vernier calipers? Vernier calipers means what? Least count is the minimum value is equal to 1 MSD minus 1 VSD. 1 MSD, and I showed you 10 vernier scale divisions are coinciding with 9 main scale divisions. Here I wrote a relation and I got it as 1 VSD is equal to 9/10th of MSD. And substituting all, I got it is 0.1 mm. The least count of the vernier caliper is 0.1 mm students. It can also be got by using the formula is equal to 1 MSD by number of vernier scale divisions. We get the same result, 1 MSD. Okay, is equal to 1. Number of vernier scale divisions, 1 by 10. Okay, 0.1 mm. These are the two formulas which are useful to find out the least count of any instrument. Okay, students. Okay, students, I hope you understood how to take the least count of the vernier caliper. Now we are going to learn how to measure a length, how to measure the length of any given object, or the thickness and the diameter of a sphere, or the length of a cylinder. It can be done very easily, student. What you have to do, first you have to insert the rod. Here I am taking a rod, little rod, which is inserted between the two lower jaws. It is a fixed one and it is a movable one, gently. Then after you have to rotate this and it gets fixed. Later you have to check which main scale reading is what is that just before the zero of the vernier. Okay, students, zero of the vernier. If you watch clearly, you will find the 1 centimeter of the main scale. See this? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 centimeter is just in front of the vernier scale. It is a vernier scale. This one, what I am showing. It is the vernier scale. And it is the main scale. Okay, students. That means what we have to take? We have to take main scale reading is equal to 1 centimeter. Okay, students, see the line which is just in front of the vernier scale. We took the main scale reading, it is 1 centimeter. Then you have to check which vernier scale division is coinciding with the main scale divisions. See here, the first one is not at all coinciding. The second, third, fourth, fifth is not, sixth, seventh. But see, this eighth division is coinciding the main scale reading. See this? Okay, students, check it. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, students. 1, 1, 2, 3, 4, 5, 6, 7, 8. Eighth division is coinciding. Okay, students. Already we know that the least count of the instrument is equal to 0.1 mm. Okay, if you convert it, you will get 0.01 centimeter. And what is the length of this rod? To say it is the x is equal to main scale reading plus vernier scale reading multiplied with the least count. Multiplied with the least count. Okay, students. Then put the values here. It is 1 centimeter plus VSR. It is the 8th division. It is coinciding into LC. 0.1 centimeter. Okay, students. Then it is 1 centimeter plus 0.08 centimeter. It is 1.08 centimeter. In this way, we can find out the length of anything or the radius of a sphere or anything by using the vernier caliper. I hope you understood this. Next video, you are going to learn about the errors which are creeped out in the vernier calipers. Okay, students.